We're now going to look at finding the inverse of a function given a graph. So the first thing I want to do is I want to identify this as our function. I don't yet know what the equation is. And over here we will graph the inverse of the function. So what I want to point out to you is if you notice this notation, this is not an exponent, this is notation for inverse of a function. So I want you to think of inverse of a function as one word, okay? Because there are other types of inverses in math, but inverse of a function, you have to look at all of that together. So this actually is not that difficult. It's basically just conceptual. So what we're going to do is we're going to look at this function that we're given, and we're going to write our points. So we have an input and an output. We're going to create a table, and we're just going to write down our input and our output from the table here. So I'm going to start at the far left. There's a point here. I have -2, 3. So I'm going to write -2, 3. And then I have the point -1, 0. And then I have the point 0, -1. And then I have the point 1, 0. And then I have the point 2, 3. So this is the table for my function. So in order to find the values of my inverse, notice I'm not given a graph, I'm not given an equation, all I'm given is my original function. It's actually pretty simple. All I have to do is switch the x and y values to get the inverse of the function. Okay? So that's all I have to do. Very important concept. And I mean literally switch them. So this is what we're going to do to get the inverse of the function. So our x becomes our y and our y becomes our x. So this becomes 3, -2, 0, -1, -1, 0, 0, 1, 3, 2. It's as easy as that. So now all we have to do is graph this. So 3, -2, 0, 0, -1, -1, 0, 0, 1, and 3, 2. So when we connect those, these are curved. That is the inverse of the function. So let's talk about whether or not our function is in fact a function. It should be because I declared it to be. But we also want to see if the inverse is a function. So we're going to do the vertical line test. So I'm just going to take my pencil and I'm going to make it vertical. And I'm going to see how many times that function touches the pencil at any one time. So for this function here, it passes the vertical line test because there's only one place at a time that my function touches the vertical line. However, if we were to do it for our inverse, here it touches it once, but here it touches it twice. Everywhere here it's touching it twice. So this makes the inverse of the function not a function. So we're going to go ahead and we're going to write that down here at the bottom. So f at x is a function because it passes the vertical line test. It has a 1-to-1 correspondence. Okay? However, our function, the inverse of our function, is not a function. And the reason why, and we can look at the graph and get it, and we can look at the table and get it, either place, it doesn't matter. Back out a little bit so we can see both. Is not a function because I'm going to map input to output. When our input is 0, there are many places where this happens, but I can see here when my input is 0, I get -1. When my input is 0, I get 1. Here, when my input is 0, I get -1. When my input is 0, I get 1. So notice I'm getting 2 outputs, so that makes it not a function. The other place where I clearly can see this is at 3. So when my input is 3, I'm actually getting 2 outputs. I get an output at -2, and I'm getting an output at 2. Here you can see where my input is 3, I get an output of 2, and I get an output of -2. So that's why the inverse of the function is not a function.